The zonation of ocean species is a serious issue in relation to climate change. Zonation is the movement of marine organisms to areas of the ocean with different features. It can be thought of as a more specific form of migration and is largely due to changing ocean features rather than regular time patterns. Climate change is occurring at an alarming rate. Climate change is described as long-term shifts in temperature and weather patterns. Carbon dioxide is considered a greenhouse gas, trapping heat from the sun and Earth's atmosphere. Scientists have been able to conclude that carbon dioxide concentrations in the atmosphere have steadily increased since the Industrial Revolution. This increase is heavily influenced by fossil fuel emissions as a result of human activities. Some fossil fuel emitting activities include transportation, home heating, and industrialization. Global warming has many detrimental impacts, including rising sea levels, increased severe weather patterns, droughts, and the displacement of a multitude of both marine and terrestrial species. Melting of land ice directly correlates to sea level rise, which impacts the migration patterns of various marine species. Oxygen minimum zones are areas in the ocean of relatively low oxygen. Many species of fish, like tuna, cannot survive in these zones because they may not provide enough oxygen for the fish to breathe. These species are then forced to move to places that have enough oxygen for them, which impacts their normal migration. The decrease in oxygen in shallow waters is caused by upwelling, which is when water moves away from the coast and deeper waters replace the surface water. Deep waters usually have less dissolved oxygen than shallow waters. Usually the surface waters are oxygenated. However, if oxygen is unable to be absorbed, then these waters will have low oxygen concentrations. This also changes the biogeochemistry of the water by bringing in or taking out minerals needed for the species in oxygenated waters. Oxygen minimum zones continue to rise to shallower waters because of climate change. The warming of water reduces oxygen pools, making areas more likely to have lower oxygen concentrations. Global warming also causes more ocean stratification, the horizontal zonation of water, which increases the productivity of photosynthetic species in surface waters. This can also cause low oxygen zones due to the increase in organic matter from the photosynthetic species when they die and sink down in the ocean, since this process consumes oxygen. As the physical and chemical properties of oceans change due to the climate continuing to warm, the migration patterns of ocean species also change. One migration pattern ocean species use to adapt to the changing environment is vertical migration. Vertical migration can occur on both daily and seasonal timescales and involves marine species moving to different depths of the ocean in response to factors such as food, predation, and ambient irradiance, which is a measure of the amount of output light energy from the sun. Short-term daily vertical migration is known as diel vertical migration, or DVM, while long-term seasonal vertical migration is known as SVM. Zooplankton are prime examples of organisms that undergo diel vertical migration. Zooplankton move to deeper waters during the day where there is low visibility in order to avoid predation, but at night they move to shallow food-rich waters since light-dependent predators are at a disadvantage. Zooplankton aren't the only marine organisms that undergo vertical migration. Many species of fish do as well. Vertical migration amongst fish species is often for similar reasons as zooplankton, food and predation. So how does climate change relate to all of this? Scientists have already seen changes in the vertical migration patterns of many types of tuna. As oxygen minimum zones become more common at greater depths, tuna are beginning to stay closer to shallow water rather than migrating as deep as they used to. This means that tuna will experience habitat compression, meaning that their range of habitat will decrease, which could lead to changes in feeding patterns and a higher risk of predation. There is yet to be evidence of shifts in zooplankton vertical migration patterns due to climate change, but based on how it is impacting tuna, these patterns may likely modify. It is especially detrimental if zooplankton migration patterns are impacted because zooplankton act as an important type of carbon sequestration. Carbon sequestration is the transport of organic carbon into deeper waters. This acts as a buffer for climate change by removing carbon that would otherwise stay in the atmosphere. If climate change impacts zooplankton migration to deeper depths, then the impacts of climate change may grow even stronger. Horizontal migration differs from vertical migration in that it involves species movement to new places in the ocean rather than different depths. In 180 species observed, Their center of body mass, or the point that represents the center of each species' distribution by total mass in terms of location, moved northward about 20 miles between 1989 and 2019. Many species migrate as a result of seasonal temperature changes, but they usually travel back to their original habitat. As a result of climate change, species are staying in more northern locations due to warming waters and not moving back south. This is prevalent in the American lobster, red hake, and black sea bass, which moved an average of 137 miles northward. Climate change is not stopping anytime soon, and it is important to understand how species are impacted by the increasing temperatures. East Coast gray snapper, sheepshead, and spiny dogfish are all projected to move northward in the 21st century over 20-year periods. It is clear in this graphic that increasing temperatures will cause species to migrate. The impacts of climate change can be seen across a multitude of marine species and is a cause for concern, as shifts in migration patterns of marine species can impact the overall function of marine ecosystems and be damaging to the environment.